Hi, I'm James Lakinski, and this is Better Bluetooth. Bluetooth is a wireless technology that has become a very popular feature on mobile phones, laptops, video game consoles, MP3 players, and other portable devices. It enables wireless connection of headsets, headphones, keyboards, mice, printers, loudspeakers, automobile stereos, digital cameras, and even a showerhead speaker. Bluetooth was developed by the Ericsson Company in 1999 when version 1.0 was published. They formed the Bluetooth Special Interest Group with IBM, Nokia, Toshiba, and Intel and gained tens of thousands of member companies since then. Essentially, it's an internationally recognized open standard telecommunication protocol that is used for wireless transmission of digital data and audio. Bluetooth-enabled devices form a point-to-point or point-to-multipoint connection using a master device and slave devices. A master can pair with up to 7 active slave devices and a maximum of 255 parked slave devices, which can be activated by the master. Master devices form a piconet with the slave devices over the industrial, scientific, and medical devices or ISM frequency band of 2.4 GHz to 2.4835 GHz. All the devices in the network are synchronized on their own channel. Overlapping piconets form a scatternet. The master device sets up the frequency hopping spread spectrum, or FHSS, synchronization pattern over 79 channels separated by 1 MHz each channel. Bluetooth devices avoid interfering with other systems by sending out very weak signals of about 1 milliwatt in the Class 3 devices, which only has a range of 1 meter. Class 2 devices transmit 2.5 milliwatts with a range of 10 meters, and Class 1 devices transmit a 100 milliwatt signal with a range of 100 meters. The reasons why Bluetooth devices must transmit with low power are because they're mostly battery-operated devices that cause faster battery loss, and transmissions need to be kept low for minimal interference over the unlicensed frequency spectrum, which has the potential for causing interference issues due to the increasing number of devices operating on the ISM band. Because a Bluetooth piconet is a shared network, each channel is divided in time by the time division multiple access method, which allows several users to share the same frequency channel by dividing the signal into different time slots. The older Bluetooth 1.0 standard has a maximum transfer speed of 1 megabit per second, while Bluetooth 2.0 can manage up to 3 megabits per second. The most up-to-date specification is version 4.2. The primary forms of data communication over a Bluetooth connection are asynchronous connectionless links, or ACL, and synchronous connection-oriented links, or SCO. The ACL link employs packet switching where headers contain destination addresses. SCO links are used to transmit real-time audio, such as voice communication over a headset. Conventional narrowband Bluetooth transmits audio with a sampling rate of 8 kHz at 64 kilobits per second. ACL and SCO links can operate simultaneously. SCO links are established as real-time links between two devices for the duration of the transmission. Packets are never retransmitted because of the real-time nature of the connection. The Bluetooth protocol is divided into 2 parts: a controller stack containing the timing critical radio interface, and a host stack dealing with high-level data. The controller stack is generally implemented in a low-cost silicon device containing the Bluetooth radio and a microprocessor. The host stack is generally implemented as part of an operating system or as an installable package on top of an operating system. The advanced audio distribution profile, known as A2DP, is used to transmit high-quality mono and stereo audio in Bluetooth ACL mode, which is part of the controller stack and primarily how music can be streamed from your mobile phone or MP3 player to your car stereo or Bluetooth loudspeaker. The maximum bitrate is 320 kilobits per second for mono and 512 kilobits per second for stereo, which is adequate for current bit rates of MP3s and AAC files. For A2DP, the subband codec SBC is mandatory. SBC was specifically designed for Bluetooth. It has a simplified design with 4 to 8 subbands, low complexity, adaptive bit distribution, and simple adaptive block PCM quantizers. The SBC encoder first splits an input PCM signal into subband signals by using a polyphase analysis filter bank. A scale factor is calculated for each subband, which are used to calculate bit allocation and levels for each subband. After scaling and quantization, the subband samples are output in a bit stream of packets with specific headers. A2DP uses the AV Data Transport Protocol to stream music to stereo headsets over an L2 cap channel. The default frame-based codec SBC or AAC result in system latencies between 150 milliseconds to 800 milliseconds. aptX reduced the latency of their transmission to 40 milliseconds approximately. This represents a major improvement and allows for transmission of high-quality audio for video games over wireless headsets. It was shown to only improve audio quality and has viability to be incorporated as a strategy in future codec designs. Neil Smythe, one of the creators of the aptX codec, stated that reducing latency can be achieved by optimizing the wireless protocol stacks to integrate the network transmission with audio coding, or by modifying audio codecs that inherently offer low latency. The most effective method to reduce the coding latency in a transform-based audio coder is the use of shorter length transform windows, since the length of transform window decides the latency-related parameters such as the frame size, the overlapping size, and the look-ahead size. Besides optimizing the audio codec that is used to encode data in preparation for Bluetooth transmission, several researchers such as Neil Smythe and David Traynor also suggested that there are several physical changes such as multiple antennae and moving into the 5 GHz frequency band that may improve the Bluetooth standard. The future of Bluetooth is developing a robust system that can be internationally standardized and handle the demand of current market preferences such as surround sound, video game sound, and high-quality stereo systems. The fact is that wireless will remain a novelty consumer item and stay out of professional studios and live venues until latency levels can match those of cabled systems with the quality expected by audio professionals. The codecs that have been developed have certainly pushed the technology forward and improved the state of Bluetooth, but more is necessary for professional use. Thank you.